Hey folks, welcome to the NCEA Level 3 Calculus paper for integration from 2024. If you're joining us for the first time, the way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. Now, the best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about answering these questions. So, without further ado, let's get started. Alright folks, so the first question what we've got is integral of 6x tan 2x. We know that this actually integrates to just, what we're going to do is just write down 6. This integrates to sec 2x, and of course we've got to divide by the differentiation of this 2x, which is going to be 2, and don't forget the plus c. So what we should end up with is just 3 sec 2x plus c. Grades wise, this is worth an achieved, and we go to the next question. Right, so question 2, what we've got is we've got a graph, blah, 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 find the shaded region. So what we're looking for is we are looking to integrate between 0 and negative 0.4, and the graph is 40x 5x squared minus 3 over 3 dx. Now, looking at this particular one, you can actually do use substitution if you want to. The reverse chain rule, which is quite a controversial one, but you know what, it still works. I know fundamentally it doesn't make sense to some people, but you know, we try it and it always seems to work. So the way I'm going to do this is I'm going to do the reverse in this case. So I'm going to go 40x 5x squared minus 3 to the power of 3, and what I do is I go add 1 to the power and I divide by the new power, which happens to be 3 plus 1, which is 4, and then also divide by the differentiation of 5x squared minus 3, which in this case is just going to be 10x. And what you should see is the 40x will pretty much cancel out each other, because we've got 40x in the denominator and 40x in the numerator. We don't need to worry about the plus c because this is going to be definite integrals. And so what we've got here is between 0 and negative 0.4. So really we've got 5x squared minus 3. I'm going to get rid of the x in this case. So I'm going to have 5 times 0 squared minus 3 to the power of 4 minus 5 times negative 0.4 squared minus 3 to the power of 4. And I'm just going to put that in the calculator. So I should get negative 3 to the power of 4, because I'm not really focused too much on the 5 times 0 squared. Then I've got take away bracket 5 and then bracket negative 0.4 squared minus 3, and that's to the power of 4. So when I get this, I get 57.57 units. Now you could do this part fairly quickly in the calculator as well. I think you could actually go into, where is it? The integral of dx. The key thing is that if you do use the calculator, you've got to make sure that you show all the working, otherwise you're not going to get the grade for it. But in this case, we're just going to quickly check the answers. So we got 0, negative 0.4, and then it's not going to that box. There we go. That's going to be 40 times x bracket 5x squared minus 3 to the power of 3. And that's going to give me this, which is again 57.57. So grades wise, this is worth an achieved, but you do have to show your integrated function. All right, question C. So question C, what we've got is object's velocity is v of t, blah, 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 since the start of timing. Initially, the object was 360 meters from a point P. So we can say that the s of t, or s of 0, is equal to 360. Calculate the distance that the object has traveled from point P when it has reached a velocity of 264. Okay, so we need to figure out what the distance formula is. So we've got velocity formula, which happens to be 26.4 t to the power of 1/3. And so the distance, s of t, is going to be integral of 26.4 t to the power of 1/3 dt. So we're going to get 26.4 t to the power of 1/3 plus 1. Now that's equal to 4/3. And of course, don't forget the plus c. So 26.4 divided by, I'm just going to get rid of that. So divided by, if I can do this, divided by that, 4/3. So that's going to give me 19.8. So s of t is equal to 19.8 t to the power of 4/3 plus c. Now, remember that s of 0 is equal to 360. We're going to get s of t as 19.8 t to the power of 4/3 plus 360. And now we need to figure out when is the time, what's the time when the velocity is 264. So we're going to put down 264 equals 26.4 t to the power of 1/3, because that's the velocity function. And now rearranging it, I'm going to get 264 divided by 26.4 equals t to the power of 1/3. So 10 is equal to t to the power of 1/3. Then what I'm going to do is I'm going to cube both sides, because by doing that I actually just get t by itself, and t is equal to 1000. So next I need to work out what s of t is. So s of t, sorry, not s of t, s of 1000, because that's going to tell me how far it's from p. So I've got 19.8, t is 1000 to the power of 4/3 plus 360. So I should get, what do I got? I should have forgot to put this plus 360. That should give me 198,360 meters. All right, so grades wise, getting to here is going to get you an achieved, and then getting the final answer is going to get you a merit. Okay, going to question D. So with question D, what we've got to do is we've got to actually use the trig products. So hopefully this works. Okay, there we go. So the one I'm going to be looking at is this one here. So 2 cos A sine B is a sine of A plus B minus sine of A minus B. So if I go back to my recording there, cos A sine B, I've actually got cos and sine there. So now the formula was, I think it was, just going to copy it down, 2 cos A sine B equals sine A plus B minus sine A minus B. So I'm going to do that first before I even get rid of anything here. So it's got to be half of that. So because two of them is like that, so I'm going to have like 24, right? So what I'm going to do is I'm going to go write this up as 12 times sine of A plus B. So that's going to be sine of 4x minus sine of 2x. Because basically what I've done there is I've just gotten rid of that 24 there, because yeah. But anyway, so what we've got is we're going to integrate this, and that's given that y is equal to 6 when equals, find the value of that. Okay, fine. So we've got to integrate this. So I'm not going to write it as 24 cos 3x, but instead I'm going to write this as 12 sine 4x minus sine 2x dx. Now I can actually take the 12 out, and so what I'll have is just sine 4x minus sine 2x dx. Now when I integrate this, sine 4x will become negative cos 4x, and that's going to be divided by the differentiation of here, which is going to be 4, and then repeating the same process again, I'm going to get negative cos 2x divided by 2, and of course don't forget the plus c. So next I'm going to get rid of bring the 12 in. So 12 over 4 is going to become negative 3 cos 4x minus 6 cos 2x plus c. So now this is what y is equal to. I need to figure out what c is, and to do that I've got x is equal to pi over 3, and then y is equal to 6. So I've got 6 equals negative 3 cos of pi over 3 minus 6 cos, just realized there should be 4 pi over 3, and then there should be 2 pi over 3 plus c. Now I need to put all of this in the calculator. I'm not going to lie, I hate writing pi over 3 all the time, so what I'm going to do is I am going to do this. I think this should work. Let's go pi divided. I'm just going to use the answer function. This is just so much easier. So I've got negative 3 cos, actually no wait, I just want to make sure my calculator is in radians. Yep, that's in degrees. That's going to be a problem because this one I want to make sure that I work in radians. So I've got negative 3 cos of 4 times the answer, because I don't want to type 1 over 3 pi. And then I've got minus 6 cos of 2 times pi over 3. And that's going to give me 9 over 2. I feel like I've done something wrong here, and I think I realized where my mistake is. Sorry folks, I'm going to write this in pink so you can see where my mistakes are. The negative sign should have been positive cos 2x, so that should have been a positive there, that should have been a positive there. And if that's the case, that should have been a positive there as well. So now it's going to mess up my whole equation again. Okay, that's fine. Mistakes happen and mistakes happen. All right, so let's go pi over 3 again. Wonder if this will work. No, it's not going to work. I got to type the whole thing again. Okay, so negative 3 cos 4x. So cos of 4 shift answer plus 6 cos 2x. All right, so that's much better. Negative 3 over 2 is what I get, negative 1.5. So I've actually got 6. So I've got 6 is equal to negative 1.5 plus c. So then c is equal to 7.5. Now once I get that, now I need to find out when x equals to pi over 2. So if y is equal to negative 3 cos 4 pi over 2 plus 6 cos 2 pi over 2 plus 7.5. Now cos of 2 pi is 1, so that's going to be negative 3 plus cos of pi is negative 1. Just doing this by my head now. This is going to be dangerous. And then I've got plus 7.5. So summarizing this, I'm going to get negative 1.5. Looking at the answer schedule, I'm doing fairly all right there. So, okay, grades wise, correct integration gets you an achieved. I guess I would have got a not achieved for that because I forgot that little plus sign there. Correct solution with evidence of correct integration is going to get you a merit. That'd be stink, you know, forget that plus sign and you end up losing really pretty easy little grade there. All right, so let's go to the next question. So next question, what we have here is graph shows between x squared and tan squared, and find the area between the curves x equals to 1 and y equals to 0. All right, so what we've got here is basically we've got integral between 1 and 0, and we can kind of look at it in two ways, but I don't think it really matters because I would just go 3 sec squared x minus 2 tan squared x dx. Ultimately, that's what we're trying to do. Now looking at this, I know sec squared x can be differentiated to tan x, but the problem is I've got 2 tan squared x there. And what I want to show you is a little bit of a little cheeky trick here, and I'm hoping that that trick is going to work. Now, if you look at identities, we've actually got tan squared theta plus 1 is sec squared theta. So we can write tan squared theta as sec squared theta minus 1. And I'm going to do it slightly different than the answer schedule, and let's see what happens. Otherwise, I just have to restart this part of the video again. So anyway, we got 1, 0, and then we're going to have 3 sec squared x minus 2. Now tan squared x can be written as sec squared x minus 1 dx. I'm nervous because this is actually looking very simple for an excellence question. Surely it can't be. Okay, it's fine. Let's just keep going. So we got 1 and 0. Then we've got 3 sec squared x minus 2 sec squared x plus 2 dx. Integrating this further, not integrating, simplifying it, I've got just sec squared x plus 2 dx. Oh, I'm surprised at how easy this excellence question is. Like, because now when we integrate this is just going to become tan x plus 2x, and that's between 1 and 0. So then we've got tan of 1 plus 2 times 1 is 2, minus tan of 0 plus 2 times 0. So the answer is just tan of 1 plus 2. I kid you not, that's pretty much the answer right there. There we go. Look, tan 1 plus 2 is the answer. I'm surprised that this is an excellence question, because this is like, once you get the identity, you're pretty much, this is so easy. Sorry. I mean, I know it shouldn't be like this, but like I've done some horrible integration questions before in my life, and grades wise, for either integration, correct isn't achieved. So I guess we are looking at achieved. For either integration isn't achieved. So we actually have to do this to get achieved. For both integrations correct. I see what they're doing. Like if you look at this one, so they've actually split this up as 2 ways. Now I've done top minus bottom, which I've taught in the integration playlists. If you haven't had checked it out, like check out the integration in 15 hours playlist. And I talk a lot about top versus bottom, because when you get this question here, like all I've done here is basically this is the top part and then this is the bottom. So if you go top minus bottom, that's pretty much what I've done here. Yes, you can actually do this method. So in other words, you would literally be getting a merit, I believe, for this line as well, because you've actually done both of them correct. And then this ends up being an E8. That's crazy. But yeah, that's pretty much question 1. I think I've did the E question faster than I did the merit question, I believe. Anyway, let's go to the next question, folks. All right, folks, so for question 2a, what we've got is just straightforward integration. But before we integrate, we need to expand the brackets. Unfortunately, we can't do reverse chain rule or anything like that for this. So we're just going to do old-fashioned quadratic expansion. So we've got 9x to the power of 8. That's going to be 12 and 12. That's going to be 24. So 24x to the power of 4 plus 16 dx. So when we integrate this, we're going to get 9x to the power of 9 divided by 9, which is the new power, plus 24x to the power of 5 divided by 5, which is also the new power. Sorry, I should have done that in red there. And then plus 16x plus c. Cool. So we'll leave it at that. That's going to give us an achieved. And then going on to question 2b. Okay, question 2b, what we have is find the value of k given this. All right, so we've got integral of 16 and k. 3 root x, I'm just going to put that as x to the power of half dx is equal to 112. So I'm going to integrate 3x half, so I'm going to get 3x half plus 1 divided by half plus 1, and that's between 16 and k is equal to 112. So long story short, I've got 3x to the power of 1.5 divided by 1.5, and that's between 16 and k. So really, I've got 2x to the power of 1.5. That's between 16 and k equals 112. So the next step, what I'm going to do is, what can I do? So I'm just going to put this as 2 times 16 to the power of 1.5 minus 2 times k to the power of 1.5 equals 112. 2 is a common factor, so I can get rid of it. I'm going to get 16 to the power of 1.5 minus k to the power of 1.5 is equal to 112 divided by 2. 16 to the power of 1.5 minus k to the power of 1.5 equals 56. What should I do next? 16 to the power of 1.5. Let's do that. 16 to the power of 1.5. What is that going to give me? Forgot the power. 16 to the power of 1.5. That's going to give me 64. So 64 minus k to the power of 1.5 is equal to 56. Negative k 1.5 is equal to 56 minus 64. negative k 1.5 is equal to negative 8. K to the power of 1.5 is equal to 8. And then k is going to equal, what should I do, 1.5. So I'm going to raise it to the power of, that's 3 over 2, so 2/3 and 2/3. So 8 to the power of 2/3. That's going to give me 4. For a lot of working for this particular question, unfortunately, this is just worth an achieved. I feel like I took a lot less time doing that excellence question before than I did for this whole achieved question. Anyway, let's go to the next one. We've got a differential equation, and what we've given is, given that y equals 0.5 when x equals 0, find y when x equals to 1/3. So we've got dy dx is equal to 12 y squared e to the power of 3x. Now what I'm going to do is I'm going to bring the y squared to the other side. So dy over y squared equals 12 e to the power of 3x dx. So I've got integral of y to the power of negative 2 dy equals integral of 12 e 3x dx. Now y to the power of negative 2, when I plus 1, I'm going to get negative 2 plus 1 divided by negative 2 plus 1. And then this is now equal to, I'm going to get 12e 3x, and that's divided by the power differentiation of 3x, which is 3. And of course, I cannot forget the plus c. So what I have here is y to the power of negative 1 divided by negative 1 equals 4e 3x plus c. Now, just going to write this a little bit neat here. So negative 1 over y to the power of 1 is 4e 3x plus c. Now, once that's done, I know that x, when x equals to 0, y is equal to 0.5. So negative 1 over 0.5 equals 4 times e to the power of 3 times 0 plus c. Now e to the power of 0 is 1. Negative 1 over 0.5 is negative 2 equals 4 plus c, which means c is equal to negative 6. So my equation that I have is negative 1 over y equals 4e 3x minus 6. So when x is equal to 1/3, I'm going to get negative 1 over y equals 4e 3 times 1/3 minus 6. So negative 1 over y is equal to 4e 1 minus 6. And if I cross multiply, I'm going to get negative 1 over 4e 1 minus 6 is equal to y. I could leave my answer like this, or I can actually just work it out. So I've got negative 1 divided by 4e1 minus 6. So that's going to give me y is equal to negative 0.2052. Cool. So grades wise, reaching stage 1, which is achieved. So that'll be up to here for an achieved. And then for a merit is right here. Okay, so let's go to the next question. So the next question, what we have got here is graph shows below function of y equals sine squared x. Okay, so find the shaded region between the line y equals to sine x squared, y equals to 1. Okay, so we can do top minus bottom for this. I think that's probably the best way to do it. So if I was to do top minus bottom, then I am going to be looking at between pi over 2 and negative pi over 2. The top equation is y is equal to 1, and the bottom equation is y sine squared x, right? So I've got 1 minus sine squared x dx. Okay, so straight away we know that we can't actually integrate sine squared x. So what we're going to do is we're going to go to the formula sheet and see if we can pick up one of these double angle formulas right there. So we've got 1 minus, that's actually 1 minus 2 sine squared. It's not going to really help us, is it? No. What we might need to do is convert this to cos squared actually. Let's go back. So what I'm going to do is I'm going to use this. cos squared theta plus sine squared theta is equal to 1. So I'm going to write down sine squared as 1 minus cos squared theta. And let's see what happens from there. So here I've got pi over 2 minus pi over 2, 1 minus cos squared x dx. Then I've got pi over 2 minus pi over 2, 1 minus 1 plus cos squared x dx. So kind of carrying on here because I know I'm going to need the space here. So this becomes cos squared x dx. Now if I go to my, where is it, cos squared x, there we go. I'm going to use cos, this one here, the cos 2a and 2 cos squared a. I'm going to use this cos 2 cos squared a minus 1. It's a handful, isn't it? All right, give me 1 second. I'm just going to write this down so I don't forget. So cos 2x equals 2 cos squared x minus 1. And this is something that I'm sure, like the special cases that we did integration of the sine squared and cos squared. This is one of those special cases there. So we're going to get cos 2x plus 1 equals 2 cos squared x. And then cos squared x is equal to cos 2x plus 1 over 2. So basically what I have is it's between pi over 2 and negative pi over 2. I've actually got a half plus cos 2x over 2 dx. Now, if you're unsure how I did this, have a look at my integration skills playlist. And I think it's like just after the trig functions, there's the 2 special cases. I go a little bit more in depth on how to do this. But anyway, we've got this here. So we're going to integrate this, which means we're going to get half x plus sine 2x over 2. And also divided by the differentiation of 2x. So that's going to be another 2 there. And we're not going to worry about the plus c. So we've got pi over 2 and negative pi over 2. And that's pretty much it. So now what we're going to do is we're going to substitute this. So we're going to have half times pi over 2 plus sine of 2 times pi over 2 over 4. And that is minus a half times negative pi over 2 plus sine of 2 times negative pi over 2 over 4. And that's what we're looking at. Now, folks, remember that this is something that, see, what I tend to do with these kind of questions is like, I'm going to cheat. I'm not going to lie, right? I'm just going to go into menu, go into my run mode, and I've got my integral function there. And what I'm going to do is at the top, actually this one I'm going to do this first because this is just cos x squared. So I'm going to go cos x squared. The bottom limit is negative pi over 2. And the top limit is pi over 2. I wonder if this is going to give it to me in, let's see. There you go. So the reason why I do this is because, like, look, it's so easy to make a mistake in this part here. This yellow box, putting this in the calculator, there's just the probability of you making a mistake with it is fairly high, right? Like, I mean, there's so many buttons you got to press. But doing something like this, what you've actually done is you've actually shown the marker all the necessary steps. Because realistically, your marker is not going to see what you've actually input in the calculator. But what I've shown here is I've shown the yellow box, and from the yellow box I get pi over 2, which is absolutely fine. But what they don't see is how you went from the yellow box to pi over 2. So you got to think about this, right? Anytime you do these definite integral questions, I always write the full, kind of like with the substitution of the values and everything. And then I just use the calculator because it's just so much faster. Grades wise, we are looking at, and also accurate actually, don't forget, it's a lot more correct. Achieved is here and merit is here. All right, let's go to question E. All right, so looking at this question, what they're asking for you is to integrate this function and then substitute p and 0 and, whatnot. Now, the key thing to keep in mind here is that a, b, p, they're all positive they're all constants, so they're all values. So if you think about it like this, A is a constant, B is a constant, and P is obviously positive number, right? So what we're going to need to do here is we are going to need to integrate this somehow, and we need to actually bring this together. All right. Now, folks, the answer schedule, it's actually gone ahead and done it in a slightly different way. So I'm going to try and attempt this, and I'm going to do a couple of different changes here, and hopefully you can kind of keep up here. So the first thing is, because m is equal to that constants, I can take out all the constants, which is from the numerator, I can take out 4 pi a. I'm going to take that out. Then I'm going to leave r squared. So all I've got left over is r squared over 1 plus b r cubed dr. Now, there are some of you that will look at this and go straight away, yep, I can see the connection between the r cubed and r squared, and off you go. Now, if you ever get stuck, the best thing to do is to do substitution. So in this case, what I'm going to do is I am going to do u is equal to br3, 1 plus br3. Now, the reason why I'm doing u substitution right now is because don't stress too much about it, because I'm going to do this separate, and then I'm going to try and bring it back so you can kind of understand what's actually happening, because a lot of people kind of get confused with the P and O there. So don't stress too much about it. Just bear with me. So next thing is du dr is equal to, I am going to get 3br squared. But what I really want to do is I really want to have r squared and dr by itself. So to do that, what I need to do is I'm going to have du over 3b equals r squared dr. Because what I've done here is I've isolated, should have used a different color. Let me just give me a second. So shouldn't use light blue as well. Is yellow going to work? Yeah, you guys can see the yellow. So r squared dr, I want to isolate it, and I wanted to do this as well. So what I'm going to end up with is m is equal to, now this fundamentally is not correct, because the p value has to change and the 0 has to change as well. So, but I'm not worried about it right now. I'm just going to leave it as p0 for now. And r squared dr can be replaced with du over 3b, that's r squared dr, multiplied by 1 over u. And yeah, I think pretty much I want to leave it like this for now. But the other thing I could also do is, because 3b is a constant, again, this is, I know this is not the right way of doing it, but trust me, it will actually make sense. Because then I'm going to say m is equal to 4 pi a not between p and 0. But what I'm going to do is I'm going to take the 3b out now. Just bear with me. p0. And I'm going to get 1 over u du. So long story short, I'm going to get m is equal to 4 pi a over 3b ln of u, p and 0. Now, as I said to you before, we should have actually swapped p and 0, but because we know that we're going to come back and change u, this is going to be 4 pi a over 3b ln of 1 plus br cubed. And that's between p and 0. So if that's the case, then I could just say m is equal to 4 pi a over 3b. Then I'm going to get ln of 1 plus b times p cubed minus ln of 1 plus b times 0 cubed, which is going to give me 4 pi a over 3b ln of 1 plus b p3. That's going to be 0 cubed, so 0 cubed 0, that's ln of 1. No, ln of 1 minus ln of 1, that's it. And with that in the case, because I can actually, log of a minus log of b is log of a divided by log of b, log of a divided by log of b. No, I think I'm doing it wrong. So if we have log A minus log B, we can write this as log of A over B. So, or in other words, I mean, if you really think about it, ln of 1 is just 0, so we can just ignore it. So 4 pi A over 3B bracket ln of 1 plus B P cubed. And that pretty much is our final answer. Like, I think it's a really weird question because, you know, once you get that substitution done, you can kind of just work it right through. Grades wise, you have to get to at least this stage to get a merit. And then E8 and E7, considering that you can get to the final part with a minor error, gets you E7, and fully correct is going to get you an E8. And that's question 2, folks. All right, so question 3, what we've got is integral of e2x. So we're going to have e2x, write it exactly as it is. Actually, before I start integrating this, I'm going to actually bring the e to the negative 4x to the numerator, sorry. And now I'm going to integrate it. So I've got e2x over 2 plus 3e negative 4x over negative 4 plus c. And pretty much that grade is going to be an achieved. And we move on to the next question. All right, second question, we've got dy dx is 5 over 4x minus 3. We're going to integrate both sides. Well, integrating this, I'm going to get y is equal to 5 ln of 4x minus 3 divided by the differentiation of whatever's in here. It's going to be 4 plus c. Now I need to substitute the values in. So I've got 10 is equal to 5 over 4 ln of 4 times 1 minus 3. That's going to be ln of 1 plus c. Now ln of 1 is equal to 0. So c is equal to 10. So then the equation is y is equal to 5 over 4 ln of 4x minus 3 plus 10. Grades wise, that is going to be an achieved. And we move to the next question. I always laugh at this one because forever it's going to be known as the Lauren-Harris method, which I can never do, by the way. If you don't know, go and check out the integration 15-hour playlist and you'll know what I'm talking about. But anyway, we're going to do this right now. Before we start, I've got to do this long division because that's how I know how to do it. So I got 4x plus 5. I'm going to do 2. So 2 times that is going to be 4x plus 6 minus, that's going to be negative 1. Have I got this right? Yes, I have. So basically, what I've done here is 4x plus 5 divided by 2x plus 3 is equal to 2 minus 1 divided by 2x plus 3. Now I'm going to go into the integration part of it. So I've got m negative 1, 2 minus 1 over 2x plus 3 dx equals to 2m. All right, so I did by long division, but that's fine. I mean, if you know a quicker way, aka the Lauren-Harris method, go for it. So now I'm going to integrate this. So 2 is going to integrate to 2x. Then here I've got ln of 2x plus 3 divided by the differentiation of 2x plus 3, which happens to be 2. And then that's all between m and negative 1. And that's equal to 2m. Now, we're going to get some annoying kind of things that are happening here, but we just have to bear with it. So we've got 2x. So 2m minus ln of 2m plus 3 over 2 minus 2 times negative 1 minus ln of 2 times negative 1 plus 3 divided by 2, and all of that is equal to 2m. So in here, I've got 2m minus ln of 2m over 3. Then I've got minus, that's going to be negative 2. So that's going to become plus 2 plus ln of 2 times negative 1 is negative 2. That's going to be ln of 1 over 2. Now here's where things are getting interesting. The two m's are going to cancel out each other. And what I've got here is ln of 1 is equal to 0, so I can completely ignore it. And I've got negative ln of 2m plus 3 over 3 plus 2 equals to 0. Then I can say that 2 is equal to, I'm nervous about this because I feel like I'm doing something wrong here. I know what it is. That should be a 2, not a 3. Copy error. Alright, so 2 is equal to ln of 2m plus 3 over 2. Then I'm going to get 4 is equal to ln of 2m plus 3. Then e to the power of 4 is equal to 2m plus 3. E to the power of 4 minus 3 equals to 2m. And then m is equal to e to the power of 4 minus 3 over 2. You can leave your answer like this in forms of e, but there are some people that, they're like, just give me the answer. Fine, here we go. E to the power of 4 and minus 3. And that's divided by 2. So we got m equals to 25.8, and we're good for that. So grades wise achieved is going to be the integrated part of this. So this is going to be achieved here, and then merit right here. All right, so let's go next question. All right, so basically what we've got is we've got both the areas are going to be equal to each other. So I'm going to look at area A equals to area B. So if I look at area A, that's between k and 0. And the graph is 2 cos x over 2 equals, on the other side I've got pi and k. It's going to be the exact same equation there. So integrating 2 cos, I'm going to get 2 sine x over 2. And that's going to be divided by the differentiation of x over 2, which happens to be half. And that's between k and 0. And then on this side, I'm going to get the exact same equation. So I'm going to get 2 sine x over 2 divided by a half, because it's the same equation. And that's going to be between pi and k. So what I've got is 4 sine x over 2 between k and 0 is equal to 4 sine x over 2 between pi and k. So kind of keep working on this, but like the thing is, the 4s really don't really matter, because you take the 4 out from both sides, you divide it, and you're going to end up with the same equations, like the 4 and 4 disappear. You might be wondering why, but I'll show you guys. But because it's going to be 4 times sine of k over 2 minus sine of 0 equals 4. Because the 4 is just a common factor, that's why I'm being super lazy about this. Sine of pi over 2 minus sine of k over 2. So once the 4's disappear, I've got sine of k over 2 minus sine of 0 is 0 equals sine of pi over 2. Now sine of pi over 2, what's that going to be? Sine of pi over 2 is 1. So 1 minus sine of k over 2. So rearranging this, I'm going to get sine k over 2 plus sine k over 2 is equal to 1. So I've got 2 sine k over 2 is equal to 1. And then sine k over 2 is equal to a half. So then I have to do shift, like k over 2 is equal to inverse sine of 1 over 2. So if I do inverse sine of 1 over 2, I want to try this. Okay, I'm going to get pi over 6. So k over 2 is equal to pi over 6. Then k is equal to 2 pi over 6, or k is equal to pi over 3. Now, really important that you guys don't use degrees for this one, because if you use degrees, you're going to get, what is it going to pi over 2 over 3? You're going to get like 60 degrees, and then 60, yeah, so that's going to mess up. So just be careful with that one. So you've got to make sure that you end up with pi over 3 for that. No, actually, no, you get 30 degrees. Sorry. you get 30 degrees. So k over 2 would equal 30, and then k is equal to 60. You'll get an answer of 60. And remember that you can't do that because in this graph, the x-axis is in terms of pi. So grades wise, we're looking at correct integration is achieved. So I'm thinking here is achieved, and then merit is at the final part of this answer. All right, let's go to the next question. Newton's law of cooling it is. All right, folks, so with this question, what we've got is basically it's Newton's law of cooling. You know, I think the formula is pretty much straightforward there. We've got dN, N being the temperature, I believe. Capital N is the temperature of the room. No, sorry, cup temperature of the coffee, my mistake. dt is equal to some constant and then N minus 18, because that's when in a staff room where the temperature is 18 degrees, all right? So some of the things that we have here is T is equal to 30, N is equal to 50. And then T is equal to for the hour, that's going to be 90 minutes. So when T is 90, we've got N is, what's it going to be dropping to 30 degrees. And pretty much what we've got is we just need to solve this and figure it out. And I think we get 2 equations, but let's try it out, all right? So first I'm going to work out the general equation first. So I've got dN over N minus 18 equals k dt. So this is going to become ln of n minus 18 equals kt plus c. Do I want to put this in exponentials? No, I'm going to leave it like this for now, because then it's easier for me to solve this with simultaneous equations. So when t is equal to 30, let's do that first. When t is equal to 30, n equals to 50. So I'm going to get ln of 50 take away 18 equals 30k plus c. Then when t is equal to 90, capital N is equal to 30. So then ln of 30 take away 18 equals 90k plus c. So what I end up with is ln of 32 equals 30k plus c, and then ln of 12 equals 90k plus c. So I got a set of simultaneous equations, and guys, don't waste time with this. Just go straight into the calculator and put it in the simultaneous equations. Number of unknowns is 2. Now I'm going to do k as the x value, c as the y value, and the number at the end by itself. So then I would have something like this: 30, 1, and ln of 32. Then I'm going to have 90, 1, and ln of 12. Hit that, and my x value, which is the k value, so k is equal to negative 0.0163, and then the c value is going to be 3.9561. So with that in mind, if I actually go back here, I'm going to get ln of n minus 18 equals k, which is negative 0.0163, t plus 3.9561. So I wanted to figure out when the t is equal to 0. So when t is equal to 0, I am going to get ln of n minus 18 equals, well, that's 0, so it doesn't matter, 3.9561. Then n minus 18 is equal to e to the power of 3.9561, and then n is equal to 18 plus e to the power of 3.9561. So if I do that, 18 plus e to the power of 3.9561. So that's going to give me n of 70.25 degrees. So what am I going to say? Well, was temperature when made. Okay, so grades wise, part 1 is achieved, which is here. Merit is finding the values for k and c with evidence of correct integration. And then E7 for a minor mistake, E8 for the fully answered questions. Cut scores. Now I know the differentiation in complex numbers was 19. cut score for this one is 20. So there you go. And I think 20 is being quite generous, because I mean, if you look at those 2 excellence questions before, actually all 3 excellence questions were fine. I would like to see go this 21, but yeah, you know what, that is what it is. And folks, that's pretty much question 3 there wrapped up. Anyway, folks, look, overall I found this paper quite lovely, actually. Like, to be honest, like, I've done some horrible integration questions before. This one, the first excellence question, was just a breeze, and the second one was a little bit tricky, but you know what, once you pull those constants out, you were fine. And then number 3, the excellence question, was just your standard, you know, Newton's law of cooling, which I think we did a lot of questions in tutorials before the exam. So yeah, those tutorials are worth definitely watching. On another note, some of you, this might be the last video you watch here on level 3 calculus, because most of the time people go through complex differentiation and then integration. If it is, thank you for your support for the last 3 years and whatever. But yeah, don't be strangers. Switch off all the notifications from this channel, you know, because otherwise you're just going to get bogged down with all these new videos that keep coming up. But yeah, thank you for your support, folks, and I wish you guys all the best for your exams, and don't leave anything empty. Catch you later.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.